We are in Algebra 1 on our brand new unit, Unit 14. Today's date is Wednesday, March 27th, 2019. Please put the date and your name on the paper, on your notes. All right, so just a quick review on our unit guide. Our unit guide has been shortened. We are on a quicker version of Unit 14. We have 5 lessons. We're just doing one variable. Tomorrow we're doing 2 variables. Then we're going to be multiplying, done. So today I want to get through a lot of vocabulary. We're going to be studying these things. These things right here. They're called polynomials. Let's talk about parts of a polynomial. So what is a coefficient? Does anyone remember what a coefficient is? We reviewed this at the very beginning of school all the way back in August. So if you can remember all the way back to August, or if you just remember what a coefficient is. If you have a hand up, can you please raise it with a card? If you have a card, Gunnar, go for it. It is. Write it down. It is a number that is being multiplied by a variable. Gunnar got both words 100% correct. Coming back here to Classcraft, Gunnar. There you are. 50 XP. All right, and your card is now turned in. So it's just a number. So if there's a number in front of a variable, that's a coefficient. Let's go ahead and label a coefficient. This 3 is a coefficient. This -2 is a coefficient. This 7 is a coefficient. Ooh, what's the coefficient of this term? Quiet raised hand. This term right here, what is the coefficient? It's tricky. Jose. Careful. -1, yeah. The coefficient here, whenever you don't see something, the coefficient, the number that's being multiplied by the variable, that's 1. So you can do a 1 there. That is also a coefficient. And this is technically not a coefficient. This is not a coefficient because there's no variable. It has to be something with a variable. Since there's no letter, that's not a coefficient. All right, we're going on to our next term. What is a variable? Quiet raise hand if you want to take a guess. As what is the variable? Go for it, Julian. Exactly. This is a number that we don't know yet. And if you don't like the word number, you can use the word symbol. Either of those are okay. So Julian, thank you, thank you. So, and that's pretty basic. That's what we're studying basically in Algebra 1. That's a variable, that's a variable, that's a variable, that's a variable. All these x's are variables. It's just a symbol. I could have used symbols from up here. There's Greek letter symbols. We'll be touching more of those next year in geometry. But it's just some symbol, some number that we don't know yet. Constant. What is a constant? And again, yeah, Josie. It's just a number. And it's a number with no variable. So, after I did I give Julian his XP? I did. So, Josie, there's your XP. I need someone else with a quiet raised hand. Can someone identify a constant in this polynomial? Where is the constant? Jenny. 17. This is our constant. So, I'm going to try to color code this a little bit better. If I grab this and change it to green, that means that this green, this is our constant. And I can underline instead of doing an arrow. This is our constant. Notice that there is no other constant up here. It's just the number. Number with no variable, just the 17. All right, thank you, Jenny. And I keep forgetting if I did not do that. Okay, so Jennifer, there you are. And your card is now in. All right, what is a term? Again, what is a term? We've reviewed this before, but what is your definition of term using what I have? I see 2 people that have hands up, but neither of them have cards. I'm giving preference to people that have cards. All right, Gunnar, go for it.
Plus or minus.
Yep, a plus or a minus. So it's a plus or a minus. So it's numbers and or a variable separated by a plus or a minus. So what I'm going to do here is I'm going to identify a term. This entire 3x to the power 4, this whole thing is a term. This -2x to the power of 3, this whole thing is another term. This whole +7 x to the power of 2, that is also a term. Each of these parts, because they're separated by a plus or a minus, each of these is a term. This is a term, and this is a term. I'll wait so that you can copy that down. Each of these little segments are terms because they're separated by a plus or a minus. So it's a kind of little compact unit. All right. And now let's finally define a polynomial. I told you that this whole thing was a polynomial. Why? What is the definition of a polynomial? What did we just define? Use that word. Monse. Yeah, it's a collection of one or more terms. That means even if I have one term, I have a polynomial. Which is kind of funny because we've been analyzing polynomials and we didn't even know it. Should I show you a polynomial that you've seen before? Are you ready? 7. That's a polynomial by this definition. This is a term because a term is just a number or a variable. This is a number and it has to be one or more. This is one term. Therefore, this is technically a polynomial. It's the lowest degree polynomial. That's still a polynomial. Should I show you another polynomial that you've been studying? 7x. That's also a polynomial because it matches the definition of it has at least one or more terms. Of course, you could have a ton of terms like this all together. And we can say this whole thing, let's use red here. This whole thing is a polynomial. All right, and then this is a very key word that I'm about to define. Degree. Not how hot is it, it's 48 degrees, but it applies to polynomials. And I don't think I've ever taught anyone this, so I'd be surprised if you knew this. Does anyone want to take a shot at it? Yeah, Gunnar, go for it. Well, it's actually something of the precipitation. No, I'm just kidding. But you can't use degree in its own definition. It's a circular definition. It's like saying the definition of constant is, oh, it's a constant. It's a circular definition. You can't have the word degree in the definition. This is the biggest. Write it down. This is the biggest exponent. The biggest exponent in all the terms of the polynomial. So let's come back up here to our polynomial. Can someone identify the biggest power, the biggest exponent? Who can do that for me with a quiet raised hand? Which one is the biggest exponent out of all of those? Sergio? 4. Let's go ahead and do a big square here. This 4. This is a degree 4 polynomial because 4 is the highest power, the highest exponent. So this polynomial has degree, we'll write it degree 4. And we can do a little arrow up here to this 4. This is a degree 4 polynomial because 4 is the highest power. And I'm being kind of loose with our definition of polynomial because we will review this in Algebra 2. Technically, there's the definition where you can't ever divide by a variable, but I'm going to ignore that. That is our semi-correct definition of polynomial in degree. All right, Fist of 5. How well are you following these definitions right now?
I found a teacher error.
You found a teacher error?
Yeah, he didn't give me my XP.
Okay. Okay, Gunnar did an attempt. Sergio got one right.
I helped Gunnar with that. Mine too.
And I did forget Jose as well. All right. Fist of 5. How well are you following? All of the vocab. That was a lot of vocab. I'm not expecting very many 5s, but most people are giving me 4s or 5s. All right, cool. Let's go ahead and go on to define very special names. This stuff will be tested. All of these terms that I've defined up here is to help us talk to each other. Now Jenny can talk to Fernando and say, oh, I think you got the wrong coefficient because she knows that word. Everything is just how you talk to your peers, how you talk to Mr. Sindel. Now we're actually going to be teaching you things. I'm going to be teaching you things that are going to be tested. Special names. This is tested. If I have a degree 0 that has a very special name, a degree 0 is called a constant. Wait a sec, Mr. Sindel. You define constant somewhere else. We define constant up here. That's a number with no variable. It's the same thing. If I have something like this where I have 7, it is a polynomial that is a constant. That's why it has a definition of constant. It's really self-explanatory. If it has a degree 0, this is x to the power of 0. And last unit we said anything to the power of 0, this x is anything. Anything to the power of 0 is, shout it out. 2 people got it. Yes, it is 1. Anything to the power of 0 is 1, so 7 times 1 is just 7. That is the reason that I call this a degree 0. I really have an invisible x to the power of 0. I recommend writing that down because it's kind of cool. Anything to the power of 0 is 1. That is why this is technically a constant. What you need to know here is if you don't see a variable, it's a constant. So this is a don't see the variable. We'll write that underneath, no variable. All right. If I have degree 1, we studied these for like 2 or 3 months. If it's degree 1, that is called linear. We've studied linear equations, 2x plus 1. We know how to solve 2x plus 1 equals 0. We were solving linear equations. All right, now I'm going to define things that we haven't seen before. If it's a degree 2, so that means, off to the side here, let's do something for an example. That means something like x squared. The degree is 2 because 2 is the highest power. If it's degree 2, this is called quadratic. I'm going to let you copy that down, and I'm going to zoom back out for the big picture. This is called quadratic. 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 Like if you ride a quad with 4 wheels, quadratic. Wait a sec, quadratics. Mr. Sindel has talked about quadratics before. He said that we are on unit 14. By unit 15 or 16, we start studying quadratics. We eventually start studying things that have the highest degree of 2. So it's just like a slight little intro. All right, and then degree 3, we call these very special things. This is called a cubic. A cubic is probably one of the hardest things to remember on all of these just because we don't talk about them that often. You don't study cubics in Algebra 1, you study cubics in Algebra 2. You do need to know the vocab word for cubic though, and that's something like x to the power of 3. If I have 3x to the power of 3 minus something, 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 that is called a cubic. All right, what about 4 and 5? There are special names for them, but I don't care if you learn them. I'll show you the special name, but this is, I'll do the special name on the side that if you want to remember, you can. But I'm just going to call this degree 4. And 5 is degree 5. They do have special names, but just call it degree 4. If you see that the degree is 4, say degree 4. If you see the degree is 5, say degree 5. It's that easy. I don't want you to have to remember this stuff, but if you want to, and this is optional to copy down in your notes right now, if it's degree 5, that's called quintic, I believe. Quintic. And this is called quartic. Again, this yellow information that I just wrote down will never be tested in this class. It will be tested in Algebra 2. So that's something x to the power of 4, x to the power of 5. All right, I'm not going to do fist of 5 until I talk about the number of terms. So number of terms, again, terms is just units. How many of these units? Do I have 1, 2, 3, 4, 5? I have 5 terms for our example polynomial up here. How many terms do I have? Let's come up here. Oh, I forgot to do the 5. So if I have 1 term, that is called a monomial. I can't spell. Monomial. And I'm going to underline mono, or mono if you're talking about Mono Lake. Mono means 1. If you're studying English and you're getting ready for your SAT or some English test where you're studying keywords, if you ever see mono, then it's going to be 1. How many lakes do we have? Mono lake? We have 1 lake. That's not really a good example. I'm trying to think of a good example. I'm blanking on one though. 2. If you're riding that, no, it's not a tricycle. It has 2 wheels. What do you call it? A bicycle, so this is called a binomial. It's called a binomial. Again, root word bi. Bi means two. Bicycle, two wheels. We talked about that bistable mechanism. It was stable at two positions. And what about three, using that bicycle scenario? Well, yeah, who wants to take a guess at the whole name if I have three terms? We notice that they always end with nomial. Who wants to take a guess, Fernando?
Trinomial.
It is indeed trinomial. Again, that root word tri meaning three. I always think about bicycles when I'm talking about polynomials. Although a unicycle doesn't really transfer well to a monomial. You'd think it's a uninomial, but it doesn't work that way. All right, so we're going to be using these names together. So I have to use both information from the degree and the information for the number of terms. We know what the degree and number of terms are from our definitions up here. So I have to identify what degree am I, how many terms am I, and then put these words together. Do I have a constant monomial? Do I have a linear trinomial? Do I have a cubic binomial? You're going to be combining these two words together for these examples. Let's go to example 1, 2, and 3, starting with example 1. Someone combine these two words. Word here, word here. Combine those two words and give me the answer. What is the name of this polynomial? Julian, go for it.
Quadratic monomial.
You have the first part correct. So quadratic. Tell us why it's quadratic. Yeah, the degree is 2. Perfect. And then what is the second part? Is it, how many terms did you count? I count 1 here, 1 there. So it's a quadratic. There it is, quadratic binomial. You sound so fancy. Like if you go home and you tell your parents, I studied quadratic binomials today, they'll be like, what? Yeah, good job, Julian. All right. I need someone else to tell me how to name this polynomial. Of course, I can say it's a polynomial, but I want to be specific. What type of polynomial? Andres?
A cubic trinomial.
There it is. It is a cubic. Cubic because it's to the power of 3. Power of 3 means cubic. Cubic trinomial. He has it correct. Cubic trinomial. Trinomial because there are 1, 2, 3 different terms. Very nice. Andres, come back and give you your XP. And our final third example of this, what is the name of this one? Ooh, it's tricky. I wonder who's going to get it, Fernando.
Constant monomial.
There it is. Write it down. Constant monomial. Thank you, Fernando. Constant monomial. All you do is sandwich those two words together. You are done. All right. That is one part of our homework assignment. Again, that homework assignment in front of you, you can start doing that if you are bored in class because you've already taken the notes. You can start working on the paper assignment. That's the nice thing about the paper assignment. Everyone should have that. We're going to go on to the second part of that homework assignment, which is combining like terms by adding and subtracting. Question, Gunnar? Oh, ready to answer already? All right, go for it. Like terms. What are like terms? The same. You're really, really close. So say what you just said for the first time. The same and variable. So the same variable, that is one of them. Good guess, but not the same sign. Keep going, keep going. What other things do you have about a polynomial? Yep, there it is. The same variable and the same exponent. I heard. Same variable, same exponent. Andres was helping. Gunnar was getting it correct. All right, so this is super key. There's 2 things, and only 2 things, that you have to know when you're combining like terms. Is it the same letter? Does it have the same power? Is it the same variable? Does it have the same exponent? That's the official language, but I'm just saying, is it the same letter? Does it have the same power? If those 2 conditions are met, it is like terms. The reason we call it like terms is because They are like each other. We are all like each other because we are all humans. These polynomials will be like terms if they have the same variable and the same exponent. So a few examples before we come down here. X squared and negative 2x squared. These two are like. These are like terms because look at their letters. They both have the letter x. Look at their exponents. They both have the power 2. Even though they had different they had different coefficients, they had different signs, I don't care about any of that. I only care about the variable. I only care about the exponent. Advanced rule right here. This is something that you don't need to know for today. You will need to know this for tomorrow. CB squared and 3CB squared are also like terms. These two are also like. Now I have the same collection of letters, C and B, C and B. C was to the power of 1 here and here, so those are both the same, and B was to the power of 2 and 2. Both the letters and the exponents for the entire term have to match. So this is just a preview for what we're seeing tomorrow. All right, coming back here. We are only allowed to add and subtract what things? What things are you only allowed to add and subtract in polynomials? And it's the keyword that I just defined on the left. On the left column. Combining, Jessica. There it is. Like terms. You can only add and subtract like terms. If they are not like terms, let me give you an example. 3x and 1. These are not like. These are not like terms because they do not have the same letter and they do not have the same exponent. These are not like terms, which means you cannot add them. You cannot subtract them. You are done. You can't do anything. You can only do things when you have like terms. So, who wants to take a shot at example number 4? I need to find the like terms and then combine those like terms. I see 1 hand, 2 hands, 3 hands, 4 hands. Jose, go for it.
So, 8x plus 2.
The answer is indeed, I'm going to do this in red, is indeed 8x plus 2. Because which two terms were the like terms? Jose?
7x.
These two were the like terms. Thank you. These two were the like terms. 2 is not a like term. 2 is different, so I can't do anything with this. I leave the 2. I can't do anything. All right. I need a fist of 5. How well are we following up to here? How well do you understand combining like terms? I see mostly 4s, a few 5s, actually about half 4s and 5s. All right, nice. All right, so these are the problems that you will see on the homework, like example 5 and example 6. How do you do these? So if you have a plus sign, all right, thank you. If you have a plus sign, it's easy. If you have a minus sign, it's a little bit harder. Whenever you have a minus sign, you need to distribute the negative sign. So I'm going to jump down here to example 6. This negative is going to be distributed into each of these terms. There's actually a cool way to show that. Instead of doing arrows, what I can do is I just flip all 3 of these signs. Ready? Here I go. I want to flip the negative, it becomes positive. Flip this positive, it becomes negative. Flip this negative, it becomes positive. I change each of those 3 signs. Now, these are both the same problem. Now they both have a plus in between. So the main takeaway from subtracting polynomials, distribute the negative. Whenever you have a minus sign in between, distribute. If I didn't have a sign in between, that would be multiplying. That's going to be less than 3. So don't worry about him yet either. All right, now that I have a plus sign, drop the parentheses. I'm going to drop the parentheses, so scribble out the parentheses, scribble out the parentheses, scribble out the parentheses, scribble out the parentheses. Drop them. They are gone. Vaporize them. Destroy them. They are invisible. Now it's a nice, easy addition problem where I need to identify the like terms and then combine. Who would like to take a shot at example number 5? I see 1 hand. I see 2 hands. I see 3 hands. I see 4 hands. I'm going to wait for 5 hands. All right, Jessica. All right, so I see these 2 things. I'm going to underline them in green. This entire negative 7y. And I really like how Jessica said that. She didn't say 7y. She said negative 7y because that negative is part of that term. And she said 2y. And then those combined to be what, Jessica? Negative 5y. Perfect. Perfect. And you want to do the next one as well? Is that okay? All right. So now our other like terms are what and what? 6 and negative 2. Again, Jessica did that perfect modeling strategy. Negative 2. Not just 2, but the negative sign as well. And 6 and negative 2 combine to make? Careful. 4. There it is. And there's our final answer. All right, thank you, Jessica. All right, who wants to do example 6? I see 1 hand. I see 2 hands. Go for it, Andres.
Okay, so for this one, you have to take out the parentheses.
Yep, get rid of the parentheses.
Since you turned it into an addition problem.
Yep. Okay, parentheses are now gone.
And now it's 6 minus 2, which is 4.
Oh, be careful. So I have a 6 here, I agree. But remember, we changed the sign over here.
Never mind.
So 6 and a
Okay,
positive
6
2.
plus 2, which is 8.
All right, so we got an 8 there.
And
Perfect.
Negative 7y minus negative 2y equals negative 9y.
Yeah, so we have a negative 7y, a negative 2y. That makes a negative 9y. Final answer, box it. Thank you, Andres. Before you write your summaries, fist of 5, how well did you understand the entire lesson? The entire lesson. Oh, wow. I'm getting some Spock signs, which I think is a 4. Getting some 4s, 4s, 4s. The lowest score that I see is a 4. I only see 4s and 5s. Awesome. That's a 3? Okay. So lowest score is a 3 then. All right, go ahead and write your summaries now. You already have the paper assignment, so when you finish your summary, you can begin on your paper assignment.